Welcome to polar curves and tangent slope. So the idea here is just like with parametric curves, ultimately tangent slope needs to be dy dx. So just like with parametric curves, tangent slope is still dy dx. And again, just like with parametric curves, we can take advantage of the chain rule. So once again, we take advantage of the chain rule. So we know that dy d theta should be equal to dy dx times dx d theta by the chain rule. And that therefore gives us that dy dx is dy d theta over dx d theta. So the question becomes, how on earth do we find dy d theta and dx d theta when our equation is in r and theta? So we have a little useful formula. So recall, to convert from polar to rectangular, we use x is equal to r cosine theta and y is equal to r sine of theta. So what we get then is if r is equal to some function f of theta, then we have that x is equal to f of theta times cosine theta, and y is equal to f of theta times sine of theta. This therefore gives us that dy dx, which is dy d theta over dx d theta, can be found by simply applying the product rule. So if y is f of theta sine of theta, then dy d theta would be f prime of theta times sine of theta plus f of theta times cosine of theta. And that's just applying the product rule to f of theta times sine of theta. Similarly, dx d theta, if we apply the product rule to x equals f of theta cosine theta, we have f prime of theta times cosine theta. And then for the second component of the product rule, derivative of cosine is negative sine. So we have minus f of theta times sine of theta. So again, if r is equal to f of theta, then we have this formula for dy dx, which is just stems from using that conversion from polar to rectangular coordinates. So for example, let's consider the polar equation, r equals 4 cosine of theta plus 1. Our first job is to find the formula for dy dx. And then find the tangent line to the curve at theta equals 5 pi over 6. So to find dy dx, we have r equals f of theta is 4 cosine of theta plus 1. Then we have f prime of theta is -4 sine of theta. So we can go ahead and fill in our dy dx. So dy dx is, again, we do f prime of theta times sine of theta plus f of theta times cosine of theta all over f prime of theta times cosine of theta minus f of theta times sine of theta. F prime was -4 sine theta. So we have a -4 sine of theta times sine of theta. Then we have plus f of theta cosine theta. So we have plus 4 cosine theta times cosine of theta. 4 cosine of theta plus 1. Then that times cosine of theta. Then in the denominator, we have f prime of theta. So -4 sine of theta times cosine theta. And then we have minus f of theta, so -4 cosine theta plus 1 times sine of theta. So if we simplify a little bit, we are looking at 4 times cosine squared of theta minus sine squared of theta. The 4 multiplying both the cosine squared and sine squared. And then we have an additional plus 4 cosine of theta. Sorry, just plus cosine theta, no 4. An additional plus cosine theta. And then this is all over. We have a -4 sine theta cosine theta minus a 4 sine theta cosine theta. So we have -8 sine theta cosine theta. And then we have a minus sine theta. If you wanted to do a little simplification, cosine squared theta minus sine squared theta is cosine 2 theta. So we have 4 cosine of 2 theta plus cosine of theta all over -8 sine theta cosine theta is a -4 sine of 2 theta. And then we have minus sine of theta. So this is our dy dx in slightly simplified form. Once we have dy dx, we can certainly find our tangent line. So next step is the tangent line. Theta equals 5 pi over 6. So we need a point and a slope. For our point, if we know our x equals f of theta times cosine of theta, and y equals f of theta times sine of theta. Here theta is 5 pi over 6. f of 5 pi over 6. F said that we did 4 times cosine of theta, so 4 times cosine of 5 pi over 6, and then plus 1. Cosine of 5 pi over 6 is a negative root 3 over 2. So we are looking at 4 times negative root 3 over 2 plus 1, or negative 2 times root 3 plus 1. So this is our f of theta. This means that x would be equal to, or x of 5 pi over 6 should be equal to negative 2 root 3 plus 1 times cosine of 5 pi over 6. Again, cosine of 5 pi over 6 is a negative root 3 over 2. So we are looking at negative 2 root 3 plus 1 times a negative root 3 over 2. Negative 2 root 3 times a negative root 3 over 2 becomes root 3 squared, or just 3. And then we are subtracting root 3 over 2. So this is our x coordinate. Y of 5 pi over 6 would be negative 2 root 3 plus 1 times sine of 5 pi over 6. Sine of 5 pi over 6 is 1/2. So we have a negative 2 root 3 plus 1 times a positive 1/2, or negative root 3 plus 1/2. So our point is, therefore, we had 3 minus root 3 over 2, comma, negative root 3 plus 1/2. For our slope, we have dy dx was equal to 4 cosine 2 theta plus cosine theta over negative 4 sine 2 theta minus sine theta. So we have 4 cosine of 2 theta plus cosine theta over a negative 4 sine of 2 theta minus sine of theta. Theta equals 5 pi over 6. We have dy dx is 4 cosine of 5 pi over 3. 2 times 5 pi over 6 is 5 pi over 3, plus cosine of 5 pi over 6. And then that's all over negative 4 times sine of 5 pi over 3 minus sine of 5 pi over 6. Cosine of 5 pi over 3 is a positive 1/2. So we have 4 times 1/2. Plus cosine of 5 pi over 6 is minus root 3 over 2. Then we have a negative 4 times sine of 5 pi over 3 is a negative root 3 over 2. Then we are subtracting off sine of 5 pi over 6 as a positive 1/2. So we wind up with 2 minus root 3 over 2 all over 2 root 3 minus a half. Or if we multiply the numerator and denominator by 2, this is equivalent to 4 minus root 3 over 4 root 3 minus 1. Of course, we could rationalize the denominator if we wished. I'm going to leave it as is. So this is our slope. So our tangent line we know our point and we know our slope. We have y minus the initial y value is equal to our slope, 4 minus root 3 over 4 root 3 minus 1 times x minus our initial x value. So our x value is 3 minus root 3 over 2. Oops, sorry about that. So we have a 3 minus root 3 over 2 for our x minus component. The y minus component, our y coordinate was a negative root 3 plus 1/2. So we would have y minus, in parentheses, a negative root 3 plus 1/2. So this is the equation for our tangent line to our polar curve at theta equals pi over 6. So ultimately, it's the same as calculating any tangent line. Once we have our point and slope, we are good to go. The main thing here is we do have to do our conversion from polar coordinates to rectangular coordinates using that x equals r cosine theta and y equals r sine theta. So that is finding tangent slope and tangent lines with polar curves or of a polar curve.